Welcome to my channel. Today I will discuss mixing tank model. Water is being pumped into a tank at a steady state rate Fn, while water is simultaneously being drained from the tank at a constant rate Fout. The tank has a fixed width and length, so its cross-sectional area A remains constant. At the beginning, the tank is completely empty. As time passes, the water level inside the tank changes. Create an equation that describes how the water level H changes with respect to time t. Develop the equation using a mass balance approach, taking into the account the given parameters F in, F out and A. Now here one tank is there. This is the tank, and tank area, cross-sectional area is A. At T and Ft in, that is the steady state flow rate that is comes into the tank, and Ft out, that is the liquid drain from the tank. So initially at T is equal to 0, the volume of the liquid water, that is actually 0. V is equal to 0. You can see from here. At the beginning, the tank is completely empty. Now, as time passes, what will happen? The liquid level will rise. Now we have to develop one model how liquid level H changes with respect to time t. To solve this problem, so here I have the figure. Already we have drawn the figure. So here Fn is the inflow rate of the liquid, that is meter cube per second. Though it is the unit is not given, so I am putting that the unit meter cube per second. So that is volumetric flow rate. F out is the outflow rate of the liquid, meter cube per second. So again that is also volumetric flow rate. V is the liquid volume in the tank at T, and H is the liquid height at the tank at T. Means when the time passes, H and V will change. H and T will change. So now before developing the model, so first we have to take the assumption. So here assumption is fluid is perfectly mixed. Number one assumption, the tank has a constant cross-sectional area, means A is constant, and then liquid is incompressible, means rho is constant, and liquid density is constant. Okay. There are no external force acting on the liquid except gravity. Okay, gravity is acting on that. And then flow rates F in and F out are constant. So F out and F in, that is constant. Now we have to balance, we have to develop the model. So first, model mass balance equation. So we know that model mass balance equation means rate of accumulation of mass is equal to rate of inflow of mass minus rate of outflow of mass plus rate of generation of mass minus rate of consumption of mass. Now as here no chemical reaction is happening inside the system, so we can discard that two terms. So rate of generation, as no chemical reaction, so this term will be 0, and rate of consumption also 0. Now we have only rate of accumulation of mass is equal to rate of inflow of mass minus rate of outflow of mass. Now, so rate of accumulation of mass, so now we know mass means rho into V, and rate means rate means d by something dt. So rate of mass means what? D m by dt, that is d rho V by dt. And rate of inflow of mass, that this is the volumetric flow rate, so mass flow rate will be volumetric flow rate into rho. So Ft in into rho, so that is inflow of mass, outflow Ft out into rho, so that is outflow, that is a rate of outflow of mass. Now here that rho is constant. As rho is constant, so our equation become, so rho will be constant, So dV by dt is equal to Ft in minus Ft out. So we'll get this equation, means rate of change of volume is equal to rate of inflow minus rate of outflow. Now volume height relation. Now we know, assume the tank has a constant cross-sectional area A and you can relate the volume V to the liquid height H. So V is equal to A into H. Now substitute the relationship between volume and height into the mass balance equation. So dAh by dt is equal to Ft in minus Ft out. So dAh, so here A into dH by dt plus H dA by dt is equal to Ft in minus Ft out. So here, as that cross-sectional area is constant, so dA by dt will be 0. So finally we will have A dH by dt is equal to Ft in minus Ft out. Now if we rearrange, then dH by dt is equal to Ft in minus Ft out by A. So this is our model equation. Now here we can, this equation actually gives you the rate at which the liquid height changes in the tank over time, considering the inflow and outflow rates. Now this is the first order ordinary differential equation. Now boundary condition. So this is the first order. So one boundary condition is equation is required to solve this equation. We already know T is equal to 0, H is equal to 0. Means at the beginning of the process, so there is no liquid, the tank is empty, so H is high, there will be no height of the liquid, so H is 0. So now this is the first order OD. We can solve using this boundary condition, and we also can calculate in different time what will be the liquid level. That's it. Thank you.